All right, so we have BCl2H here. And first thing we need to figure out is what's the central atom. So let's write them all out. Put in the dots. And then we have Cl and H. All right, so out of these three, we have boron that can bond to the most things, right? So that's going to feel pretty much like a central atom. So let's do that. And then we'll connect everything else to it. So we have 2 Cl's and 1 H. Doesn't matter how you put it. But in general, you kind of want to put like things next to each other. Now, it doesn't matter for this because they're all going to be kind of next to each other. But if it was like a tetrahedral, and you had 2 chlorines and 2 hydrogens, then you'd want to put the chlorines next to each other. Okay, so the chlorines are next to each other, hydrogen over here. But again, it doesn't matter for this because they're all pretty close to it. Okay, so we need to figure out AXE. All right, so let's do that first. So A, X, X, X. All right, so we have AX3. That's going to give us trigonal planar. All right, so trigonal planar AX3, the bond angle for that is going to be 120 degrees. All right, so we're good, and dipoles. All right, last thing we need to take a look at for this one are the dipoles. So let's check out the electronegativity of everything. Boron is 2, chlorine is 3, hydrogen is 2.1. All right, so this molecule you can see is more electronegative where the chlorines are. Now, if we draw this a little bit cleaned up, which actually looks pretty good over there. But if we just kind of look at this, you can kind of cut this molecule in half and say that there's one side of it up here that it's all like the chlorines, and then the other side, the hydrogen, is over there. And when you do that, you can see that the chlorine numbers are higher. So this is 3.0, this is 2.1. So we could figure out that this is polar because there's a difference as we go across this way. From 2.1 and 3, we get 0.9. So we get 0.9 going towards the chlorine side, which means the chlorines are going to be slightly negative because they have the higher number, and then the hydrogen is going to be slightly positive. All right, we can kind of think of it as being cut in half, kind of through there. Now, with this being in the center here, this 2.0, the center ones you can kind of ignore. You really want to focus on the outer ones. And even if you looked at the one in the center, it would still kind of work because, again, it's 1 going from the boron to the chlorine. So you're still going to have this pull towards the chlorines. Right? So that's going to give us a polar molecule.